Right. I think we can get started. Cool. Doo-doo. Just gonna double check that everything's right. Excellent. All right. I think I will just start. Cool. Quick audio check. It appears that I can be heard. That's good. All right, let's get started. Where were we? Right. We set up a repo before and we started beginning the grammar. We had a couple of files that we really wanted to, things that we really wanted to do. Okay, so I pop this up. Come on, Vim. Show me my changes. Right. I guess the next step from here, right, the thing that we will do today would be to begin our parser, right? So we can start defining what would be valid constructs in our little language, right? And writing a couple of tests for that as well. I think that would be nice. I think that could be a good goal to have for today. In the process, we will definitely visit and revisit the syntax to make sure that what we're building makes sense, right? Is comfortable to use, actually is easy for someone to pick up, and ultimately can be turned into a useful program. Cool. And we had some wish list, like some things we really wanted to, like I guess wish list or QLang, things that we would really like the language to have. One of those was nice and terse list manipulation syntax, right? So I think the last thing we added on the last stream was work on the lecture, right? For getting things like, for example, non-empty lists, right? Working, but also empty lists with brackets. We haven't really done any work here to accept the kind of symbols that would allow us to do pattern matching, I think. Maybe we have. We don't have something like head or tails right now. Anyways. parser module up and running. Parser rs, right? Look back into how this was done for lore, right? And I think we defined the AST in a separate the AST module here. Go to parse tree, yeah, definitely. And this was a pretty small definition of an AST. Okay, so we can just keep that. Some parser errors and so on. And we have our parser here. I guess we build it with a path to the file that we're gonna parse, and then with the actual contents of that file. We don't really need this right now. We could just use the source file, right? The source string. At the end of the day, that's sort of what we're doing here. We're whatever you pass in, you end up in for string. Do you? No, never mind. Oh, you are sort of reading the file into memory. We could make this a lot better, but hey, how's it going? Yeah, just looking at the lore parser just to get some ideas to do it again for QLang. So I think we'll just start by defining the struct here, right? And the parser itself is just going to have some file. What do we call it? Source, I think might be better. Just as a string right now. I don't know if I have a take. I think I really like OCaml for doing this sort of work. Just the type system is so much linear, right? In some ways, I guess. And I have to think a lot less about, well, how will this sort of be efficient? Because, for example, I'm writing this parser struct, and I know already that I don't want to have this string that's owned. I actually would like to have, a pointer to somewhere where the string is, so maybe we don't actually have to copy that data around at all, right? We're just always referencing the same string somewhere. And this is some complexity that the language maybe surfaces for me, whereas Camel, I would have never thought of that to begin with, right? And here is like pretty on the nose that, oh, I see references to data all the time versus, oh, this is just a string and you can just use it, right? But then on the other hand, I do feel like Camel maybe detaches me from the execution of the program a little bit. Not that I can't think of how it will be executed, right? I can. Jane Street has proven that time and again. They can write OCaml that runs really, really fast, right? Because they really understand how the GC works there and so on. But for the most part, when you're writing it, you're sort of working in this like very abstract space, right? We're just manipulating symbols, which is exactly what it's for, right? Like it's after all, it is what do you call categorical abstract machine language, right? Language. I forget how to write. So it's kind of perfect for that. Now, on the other hand, when it comes to what happens after you define like your lecture, your parser, your type system, and you know all this stuff already, Blaine. When you have to do like the code generation and stuff, I feel maybe the Rust ecosystem is more complete, or it has better tools for that, right? Because a lot of people are using it at lower levels. DynoCamel, what do you think? Like, do you think that it has a particular killer feature for writing languages versus Rust? But do you have like a take? Yeah. Well, for the lecture, we're using logos here. It's fine. Like I've used it in a couple of tiny toy languages by now, right? And it does the job just okay. It's very much terser than using something like Manure for this, right? I think we had an example here. Yeah, Manure here. Yeah, it is macro based. I think we can open the docs here to have a look. Docs are as logos. There you go. Apparently, it creates ridiculously fast lectures. So, are you trying to avoid one that is macro based? Because you can always roll your own sort of lecture, right? Maybe. I don't know. I feel like even Camel, like we're using something like Manure, and we look at this thing and say, oh yeah, this looks like a camel, but it's not, right? So if we had to write a lecture on our own, then it will be harder than it is. Like I mentioned this before on the last stream, but for the new caramel syntax, I wrote a lecture, right? Also from scratch. Like this is the lecture type, right? And this was sort of inspired by the Rescript new syntax lecture as well. And this is a lot more work, right, than using something like Manure for the lecturing, right? In this, I think it's the exact same case with Rust macros or without them, right? Like the best you could get is a sort of library that does the job of chunking a piece of text, right, and sort of keeping track of the current character and stuff like that. But you will still have to build the main sort of scan loop, right? Going character by character and saying, oh yeah, when you find these 2, 3, 4, 5 things, go into this particular subsection of the lecture, right, to find number tokens or whatever. So like, how do you make the decision there, which one to go for? And I guess we'll just do parse, and we'll consume the parser. No home. Yeah. Sorry, I got distracted by someone honking really loudly outside. Yes, that's correct. I think at least if you were to read the sources of Manir, right? But otherwise, this stuff is like, I guess this part is standard camel up here, but the rest that we have down there is this standard camel. This doesn't look like it to me, right? Like we have parse, or, and then they have these or expressions, right? where you have something to match on and then what to do with that. Like maybe this expands to something that is standard OCaml. My guess is that if you look at the expanded, you know, lecture, the generated lecture is not going to look very readable. It's going to be just, you know, something that's meant to be fast, not human readable. Yeah. But I do hear your point, right? Like at some point we want to be able to understand most, if not everything that we are working on or on top of. I guess there's just trade-offs here, right? Like I want to get the lecture up and running as soon as possible, right? So I can focus on some more interesting things, right? And I have two options. Either I don't write a lecture, right, and just start with the sort of standard tiny programs that are described as data structures, right, which would be okay. Or I just, I don't know, use something like this that gives me almost for free, right, this, you know, string to tokens functionality capability. After that, after a while, I guess, if the interface is very well defined, right, like the tokens in the middle, then I can drop this thing and just write a lecture by hand, something that I understand exactly how it works and how it's doing its thing, right? I guess the same thing is to be said of parser generators, right? Like BNF grammar macro-based solutions. Like when you go to the parser here and I read this thing, sure, it's kind of concise to understand, but I've done this before for the Erlang parser as well. Sorry, yeah, I think it's this one. And this thing just became unmaintainable. Like there were so many tiny edge cases here and there that were really hard to navigate and understand. Because again, we're not writing the language that we are led to believe we're writing, right? We're writing on this meta language that the macro system of Manure understands. And sure, it's not macro as in like a Rust macro, right, or a Racket macro, but it's still, you know, another language that is used for generating OCaml. Don't know if that makes sense. Yeah, yeah, I hear you. I feel like if Logos was broken, I would be completely screwed. I would have to essentially sit down and just hand roll a lecture. Now I'm wondering what does the Logos library look like, right? Let's see. Let's look at the repository. Clone you. Dope. Logos code jam, derive. Let's see if there's a readme somewhere here. Contribution, no, just a readme, okay. No, I'm looking for something that gives me an idea of where to go, where to start, right? So procedural macros, we have quote, we have sin. I don't know what beef and FMB are. Let's see. If there was a bug somewhere in here, I'm pretty sure I would get lost. this will be a massive detour. So we get a token stream, and this will be our enum, I guess. Yeah, parsing that. Cool. Get the name. Getting a little error there. Parsing the genetics. Okay, ropes and graph. What are we using the ropes and graph for? Is this generator rope? Pattern. This. I feel like I'm missing some domain knowledge here. What is a rope expected to be in this context? Let's see. Lecture generator. Actually, let's just go for graph rope. Yeah. Okay, so a rope is the data structure. Very long strings. Is it though? So this doesn't look like a tree to me. Unless maybe the node ID somehow. I don't know. Maybe it doesn't look like the kind of tree I'm used to. But this, the sort of vector range pattern, we have something similar in the example here, right? They have a DQ of rope-like, and they have a stack. I don't know what this is. Oh, this is an operation. Never mind. My bad. Don't have an example that I can see. Copy and write behavior. Leave nodes usually implemented as basic fixed length strings with reference count. Okay. Yes. So as you can see, if there was a bug somewhere in here, I would have to sit down and learn stuff to be able to go there. But I'm pretty sure that will happen with Manure as well, right? Like Manure is a rather complex piece of software. What was the name of this library? Logos. Cool. Actually, I don't want to keep that open. Cool. So what were we trying to say? We were trying to grab a string and actually, no, we don't actually want a string here. I guess we want tokens, right? Unless in lore maybe I actually grabbed the string, and when I say parse, yeah, I build a pickable lexer. Okay, so we might need to actually steal this from lore as well. Right. So if I remember correctly, it's been a while. Oh. 2021-09, Jesus. The pickable lexer we use to keep track of what the currently pick token is. And if we have a pick token, then we return that instead. So when we're doing pick, we check if there is nothing that has been picked, right? And then we get the next token, right? Pick it and save it. But because this self lexer doesn't, okay, so maybe Blaine, this is a good point. Like the lexer that is generated doesn't actually let me pick, or at least didn't back then a year ago when I was using that version of the library, right? So I had to work around by building an abstraction, right, that wraps the lexer. So anytime I want to say pick, then I just grab the next token and save it somewhere else so I can use it later on without immediately discarding it, right? So of course having a hand roll lexer would have helped here. I would have been able to just modify that behavior. I think that would have been fun as well. 1 second. Cool. Okay, so then we're gonna need this to be able to give the parser, right, some lexer that it can actually use to get tokens, but also see tokens ahead without necessarily consuming them. Maybe it will be okay for us to start with the regular lexer, and if we need to do a look ahead, then we will do that, but I'm pretty sure that we'll need a look ahead at some point. Cool. So, okay, that will be fine. We get the source, we can just save it there. At some point, we're gonna try to start a lexer, and we can do lexer, right? And I forget how we were doing it before here in the tests. We just pass in a string, right? So this will be token, yeah. Lexer. Wait, did I call the structure lexer before? No. Huh, that's strange. I thought I did. Anyways, and here we will save, all right, self.source. I'm just gonna hand over a reference to that so we get the lexer that we can start using. But we need to turn this series of tokens into some piece of data, some tree, right? And just because I have been broken by working with a camel, I'm gonna call this a parse tree because this will be the tree that we're parsing, right? Eventually, later on, once we do other things on that, right, we will maybe call it something different, like type tree, like you would have in a camel as well, right? Other languages, I guess, would just call it AST, or maybe like, I don't know, past, I don't know, tree. So let's assume that we have a parse tree data structure that we can start working with. What we would want is to first define our unit of parsing, right? Are we gonna be starting the parsing at sort of an expression level? Would it be at a higher level, for example, on a single module, right? Like what really is this stream of tokens that we're receiving? I think it would be okay for us to mimic something in OCaml right now where you have a type that represents a structure, right? Which is essentially a module. And a module has a bunch of stuff here, a bunch of things. In OCaml, they're called module items, or structure items actually. But if we did this, then our module, right, our struct that will represent the module would essentially be a vector of different things that can be placed within a module. And that can be other things, not just, for example, variable declarations, right, or function declarations, or even some expressions, right? They could be, for example, annotations of things that were given the compiler. So let's just do this super use. I'm just going to import that. We're going to begin by making our parse tree module, right? And this will complain that we don't have the file, so we're just going to save that file, right? Boom, saved. No more complaining. That's great. So next thing we need to do is figure out that shape. Okay, so let's say we have a structure here, and we'll call this a module, right? And this module will have some items, for example. And right now we'll just say module item, so which will be something that can be defined within a module. We may also want to have, I think this is what I was trying to say before, may also have other things, right? Such as compiler annotations. If you ever seen in Erlang, for example, when you start your module, your file, right, by saying dash module, right, hello world, right, dot. This actually is an attribute of this module that you're compiling. Is a way of telling the compiler, here's more information for you to compile this piece of code, right? And they usually have the same the shape of like a dash, and then you have a name, and the name is an atom, and then in parentheses you can have any expression, which is interesting. I don't think all expressions are allowed here, but you can do all sorts of crazy things like, you know, tuples or tuples or of lists, and just include both all sorts of values, literal values here, like booleans, numbers. You can have big nums as well, just by writing really big numbers, right? I think some expressions are allowed, some other expressions such as numerical expressions, for example. I'll need to double check that. And this is sort of what you use to talk to the compiler. So you will normally see things like telling the compiler what the name of the module is, which is great. I really like that about Erlang, because it uses this information, right, to enforce that the module you're defining is actually in a file called the exact same thing, which means it's really easy to look at a file and know, oh, this is the module that is here, right? It's defined here. And then other things such as what functions will be exported, right? So let's say we want to export a function called new that takes 2 parameters. It will be like that, right? This is how we're telling it. We have an attribute called export. The value is essentially this little tuple, right? That says the atom name of the function and then the RET, how many arguments it has, and you can have as many as you want, or I guess fit into this list. So we may want to have something like that later on to communicate with the compiler. Right now, since we just want to say I want to build a module, right, and we probably want to give the module a name, so we'll just say there's a name. We may have more information later on, like what the file of that module is, and we will have a bunch of items in that module, right? So again, we do module item, and I think this will be an enum better, right? Module item. All right, so going back a little bit to the language that we were trying to define, I think we do have this notepad where we were typing a couple of things. Which one was I using? Okay, on camera. And we were trying to get this to parse. So for the time being, we're gonna say, all right, one module item is going to be a declaration, right? Or, yeah, I think that'll be okay. And we can actually put this as a separate struct somewhere else. Yeah, going back to that question of like whether I use Rust or why would I choose Rust over a camel for this? I think that at this point we're defining the parse tree, right? Or any of these sort of data structures that can be recursive. I miss OCaml so much, right? It's like if you were to just say, oh, here's my parse tree, right? You can't just say all of these types are co-recursive and they may reference themselves. You have to start thinking that, oh, I'm gonna have to box this, or I'm gonna have to introduce some indirection, right? So that some of that data will end up on the heap rather than. I think the problem is that you cannot really size something that includes itself, so you have to put the indirection in the middle, so then you size it as a pointer, right? I forget if this actually came up in lore, because the parse tree is super small. No, it did not. But yeah, we'll get to that. So now we're doing like a value declaration, and here we want to have definitely want to have a bound name, right? Like a name that we're binding this to. And before we start throwing string everywhere, I'll just use an ID and we'll do an struct, right? That will just have a single field, and we can figure out what to do that later, what to turn this into later, because maybe we want every ID to actually be, for example, a path, right? That says, oh, you are inside of this module namespace, like a.b.c.hello, right? And then the ID will be actually a vector, right? Of A, B, C, hello. Or maybe we'll just say ID is a string, right? And we'll actually have a fully qualified name. But for the time being, I just don't want to throw strings everywhere. So I'm going to put the module in there as well. And when we're declaring this, we definitely will have a values, and the value is going to be an expression, right? And here is where I think we're going to find the problem of having the expression, right? Reference itself. Before we do that, I'm actually gonna I think maybe this will be fine if I try to build it. Let's see, we haven't broken anything else. Okay, we have broken some stuff. What have we done? Oh yeah, pub function, right? And I think we'll have to do parse tree. No parse tree. Nope. Forgive me while I figure out how to use the... Okay, so I need to go through the crate. Cool. No problem. Can do. Crate, lecture, token. I want to use that. Oh, it's a private enum. Okay. So, pub. You happy now? Cool. All right. And we'll do the same for the parse tree. But I'm going to actually import everything from there. So now I should actually get something like auto completion, I guess. And I don't. Still no. What's the problem? Oh, right. We don't have a parse tree. We just have module. That makes sense. Use of undeclared crate. Mod parse tree is inside of source. That makes sense. And use import. The hell are you talking about? It's right here. What am I doing wrong? Oh, okay. This requires me to use logos. I need to bring in the trait. That cannot have been the problem. But so if I remove that, then it complains that we don't have a... Okay, then I guess it didn't get to compile the parse tree module before, so that's why it didn't it marked this as an error. That's strange. I would have expected that if you do like a graph, right, of how we have the things right now, right, we definitely have... I don't know if I can keep drawing. Yeah, so we have main, right, and this thing is defining three different things. It defines the lecture, it defines the parser, and it's defining the parse tree, right? And so far so good. That means I'm gonna say like arrow means depends on, right? If we navigate this a little bit, the main is not really using them, but it sort of depends on because he's declaring them as modules, right? If you go to the lecture doesn't depend on anything else than logos, so we'll have logos somewhere here, right? Forgot how to draw arrows. And then when we go to the parse tree depends on nothing, right? And then the parser depends on everything, right? It depends on the parse tree, it depends on lecture, and it depends on logos. So I ask you, right? Why would we wait to build a parse tree if we have an error in the parser? That doesn't make sense to me. Mad at this. Computers. All right, so we just want to return a module, and we know we actually have I'm just gonna derive a debug here, a default. And I guess I will have to define the same thing everywhere. Yay. And this won't happen because of expression. Fine. There will be no default. I will just make a module. The ID is going to be ID, my module, right? And then for items, whoa, glass of ethanol with X's. Subscribed. That's amazing. Thank you so much. Look, Ma, I got a subscriber. So I'm gonna test this thing. And this is a private field, of course. Pub. And it's not ID, it's called name. Perfect. Oh, yeah. So this is one tiny thing that just gets in my way all the time. And I don't know if because I haven't internalized yet, right? That when you build a string like I just did here, it's not really a string, it's a pointer to a string, right? Thanks. I do drink a lot of coffee, so it's appreciated. Cool. Hello? Yeah, I understand that a lot of these things are never used. That's fine. But you're telling me these fields are private. Okay. I'm just gonna start with that. Ideally, we would have, amazing, all tests are passing. I think ideally we would have a nice API for building and manipulating the parse tree. Right now, I am super happy just not doing that. Just here's the types, they're public, we can just play around with that, right? At some point, we will say, well, this is not public anymore, and we can go around fixing some of those things. But we just got started, so that would be fine. I mean, we can do that next stream, right? Okay, so the build passes, it's a bunch of unused things, that's fine. The tests seem to be okay. Oh, yeah, it's been like 3 years. I haven't streamed, in quite a bit of time. Yes. Really happy to hear that stream name again. The design system one was great. We did it with Fernando Villa, Xavier Villa is his name. And he's an excellent designer and programmer, sort of there in the middle. Yeah, I'm trying to get back to this. I think it's a lot of fun. I really enjoy doing it, right? And as I said in the last one, it really keeps me honest with the stuff that I do know, that I don't know, and it keeps me learning. So, yeah, I enjoy it. Okay, so we have that. Great. It's not going to do much, right? But it's starting. So let's go back to our examples, right? We had a couple of examples here. It would be great if we could parse this into a module, right? I'll be also happy to get just one of these two things in there. So we know that each one of these will be a declaration of sorts, right? So when we are parsing a module, we don't expect much at the beginning, right? Maybe we'll just continuously try to parse a module item and then push all the items into a module struct, right? So we can actually try to do that. So we got a lecture, and I wonder if we can just like loop, right? We'll say, okay, we get some items, and literally we'll just like loop as long as we have something in the lecture, right? Then, okay, maybe this is where the pickable lecture becomes useful, because it would be super nice to be able to say, well, let some token, right, in lecture.pick. That means we still have something else to parse, right? And then we can just keep rolling, and then eventually we'll be done, and then we can just go back. But I guess we don't have Lexer pick. We just have Lexer next. So let's see how far that takes us. Cool. Eventually we'll just put that there. And I think maybe we do want to get a name, right? When you say from string, you say both here's the sources, right? But also here's the name of this file or the module name. Let's see if some of these code actions work. Boom. Dope. So we'll do self.module name. And yeah, that tracks. Empty loop wasted CPU cycles. That's new. I didn't know that. Cool. All right, so we'll try to call self.parse module item, right? And we'll try to get a module item here, so an item. My guess is that we want to start dealing with just a tiny bit of maybe error handling in case that we don't find the right module item there, right? There's a couple of things we could do if this fails, right? We could try to collect the errors, right? And in something like, I don't know, diagnostics. So as we parse, right, along, right, we can say, well, we'll parse the next thing. In this case, is an item, but we can just match on this, right, and say, oh, it's okay. So then we have an item. Perfect. Just like do items.push, right, and get that item right there. But if we have an error, right, then we will get some form of diagnostics back. And what we would like to do here is to say, hey, Lexer, skip until, right, this section is done. And I don't quite know how to do that with the things we have in place right now, right? Because we haven't really designed the entire syntax. So I think we'll opt for an approach where if anything is wrong, we'll just completely bail, right? We might as well just like panic, right? And say, oops, something went wrong. And then we're just gonna dump like a debug representation of that error here. And I guess we can just get rid of most of that stuff. Cool. So this is pretty terrible Rust, I would say. This is not the kind of Rust that I will want to write for a system that I want to maintain, especially not panicking like this when there's a clearly easier solution. God damn it, I'm going to do the diagnostics, aren't I? Okay, fine, whatever. So whenever we get a diagnostics, we're just going to push it into the diagnostics array, right? And this will allow us to sort of keep going from whatever error we find, right? And just keep parsing things. And we will still need to figure out note, or to do rather, how do we skip until the next valid token? And there's a couple of things we can do there, right? Oh, actually, we can just do that. Skip until, right? For example, we could figure out what the last valid token would be for the current thing we're parsing and just keep until we find that, right? So one example of that is, let's say we're going back to our notepad here. Let's say we have this function, right? And this is how we define functions. Name of a sort of value that's been bound at a module level. We got an equals there, and then we have this, right? This means here's a parentheses, right? These are the arguments, arg1, arg2, right? And then we have the brace. So if we accidentally do that, right, put two braces, then when we start parsing this particular module item, we'll find the name, we'll find the equals, we'll find the parentheses, right? But once we do like a double brace there, this actually might be valid if we have something like block scope. Don't know. But let's assume that we don't. Like we actually have like a question mark. But then so many symbols that could have good meaning, right? Okay, let's say that just doesn't work. We have like an X there, right? What we would want to say is, okay, we found a weird symbol, right? We still want to be able to parse like the next function that's defined, or the next module item, which might be fine, right? I'm actually going to put this one below. So we know that every function that's defined here, because we're parsing inside here now, right? Inside of a module item, inside of a value declaration, right? Inside of an expression, and here there will be like a function, right? And the function will just be a struct that will have its own things. Because we're so deep into the parsing, we know exactly what the end of this thing would be, right? And then we can say, all right, I'm just gonna find the next close brace, because that's the last token that we would expect to have, right, when parsing a function. So in this case, it would just go through that, right, and then skip all of these tokens, and find this one, right, and then we can just build a diagnostic out of that, saying, hey, we found this thing. Oh yeah, great idea about diagnostics. There's this beautiful library called Miet. I think it's called Miet. Damn it, I got excited again. Yes, Rust. There you go. That can help us make nice diagnostics, right? So we could use something like this to say, hey, here is the precise code that we tried to parse and we couldn't. This is wrong, right? So then something like this can help us build a nice diagnostic for it. Cool. And then, of course, because we skipped all that from the lecture, those tokens are gone, right? Which means the next token you pump out of the lecture is gonna be this name, this ID, pi, and then we can continue the parsing. And by the end of the module, assuming the module sort of ends here, right? Then we will end up with like some items, right? And some diagnostics. And we can use this to say, oh, this is not an empty, like a good module. There are some things that need to be fixed. Depending on the kind of diagnostics, we could build a hierarchy of those things as well and say, some things are warnings, some things are actual errors, some things are like, I don't know, hints, right? Like if you had something like that, right? Or the same expression in both sides, if we were pattern matching. Maybe a hint would be like, oh, you don't need that. Get rid of it. And based on that, stop the compiler. For this particular file, for this particular unit, say, well, here's the errors. We go with something like Miet and just speed up the diagnostics. All right, cool. So should we do that? That sounds like something we can do. Parse module item. And I guess there will be a couple of ways to structure this, right? We could build many functions in this parser at this level, saying, parse module item, and then going deeper, like parse value declaration, parse ID, parse expression, and so on, right? Each one of these would be sort of tiny functions that know exactly how to parse one thing. We could also just play a little nicer with the trait system and just say like, okay, we're gonna make a trait, right? That will be like parse, for example. So at any point in time, we could try to use that trait to find out where the implementation of this function would be based on the type that we want, right? So if we wanted to parse this thing, we will say value declaration, right? I guess maybe the parse trait will define something from lecture, right? So you pass a mutable reference for the lecture, and then this tries to parse itself. So in here we can say implements, parse, for example, right? For value that I forget. Is this the way that we do traits? Jesus, I am blanking out. Yeah, if we did default here, then we'll be able to get the code action. Boom. So it will be a little bit like that, right? It will say, okay, here's our function from lecture, right? And then each one of the data structures will define separately how how they should consume from the lecture, right? And whatever you get out would be a data structure that says, hey, here's me, in this case, a valid declaration, or diagnostics. And I think I really like that in terms of code organization, but I haven't actually used a pattern like that just yet. So I think maybe before we jump straight into that, what we could do is look at another language built with Rust, right? And see what we can learn from that. And I think one language could be. Got any ideas? I have one in mind, but I'd love to hear what you think. Maybe you have something that you want to share. All right, so what I was thinking was Gleam, which is written in Rust. Amazing language, but Louis Pilful. So maybe we could go through this a little bit and be like, all right, core, source. My guess is that the parser is there. Let's see. It's got a lecture as well. Ooh. Custom lecture. It looks like that. Yep. Nice. And then it's got this is parse, token, AST. Let's see what the AST has. Typed, untyped. Okay. Untyped expressions. Huh. Oh, my bad. We got parse over here. My guess is that this one, yeah, this is the big one. This is where stuff happens, right? Parse expression sequence. Yeah, okay. So that's sort of the pattern that I was thinking at the beginning. It's just, you have a bunch of functions in the same parser, right? And they pass around itself, so you have access to the lexer. You can do things with that, right? But each one of these functions are taking care of a specific kind of a syntactic construct. Statement, target group. Oh, look at that module. Yeah. Cool. All right, so I'm actually gonna give the other thing a try and see where it takes us. I think it could be fun. So we've got our parser, right? And we're just gonna go for a trade here. And we're gonna say parse. Perfect. And yeah, the trade is implemented for a data type and returns itself, so it should be fine. So we'll have a function here called from lecture, right? And we'll take a mutable lecture. So this will be a token, I think. No, it will be lecture token, right? And my guess is that we will actually need this. Will it be a logos lecture? We'll see. And for result, we're gonna either get a good thing right out of that. So self, whoever's implementing it, or we are going to get some. Actually, we might actually want to not use a result like that, but just a custom like parse result struct that includes both self, right, or self diagnostics, right? But maybe we can just start with the diagnostics, a vector of that. There may be more states to be represented here, rather than just, yeah, things are good versus no, things are diagnostics. Like we may actually fail to do some operation, right? And that's not something that we can recover from. But we still need to raise that somehow and deal with it. I mean, if we can recover from it, of course. Okay, so let's just make a new module for diagnostics here. We'll go to main, do mod diagnostic, right? Cool, so we just need to create a file. So we'll do just that, diagnostic rs. Boom, if we save that, then the error is gonzo. Screw it, parse results. I guess I want a value here, right? And I also want diagnostics. So that could be empty. Self, and then we can actually use an error, parse error. We don't really have a parse error right now. If we were to do parse errors, I would say we want to bring in another crate, right? We want to bring in this error to deal with that. I don't remember what the latest version is. 1. Okay, so latest version is 1 point something. That should do the trick. Nope. Wait, didn't I save? I did. My editor is going crazy here. Okay. So we want to say that we will have an error, right? And this will be our parser error. And I actually forget exactly what this error crate demands of me. All right, so we need to essentially include that in. That's fine. Use this error, right? And we'll do a derive on our data structure. Don't know why it needs debug though. And then we have all the kinds of errors. I'm wondering, maybe we want all kinds of errors to be defined in a single spot, right? It could be useful to just have a single place. What I really miss right now is OCaml's polymorphic variants, right? Where I'll be able to just say, hey, I want the return type of this function, right, to be at least one of these variants in a list. And that will look a little bit like this. So if we add from lecture, right, the type will be some lecture. I'm actually just going to use rescript syntax since it'll be easier to map here. Parse result, and then we will have some t that we're working with. And for the error here, right, we'll be able to say, well, I will want one of these different errors, right? And in this syntax that looks super wonky, this one over here, I'll just pull it outside, right, would allow me to say this is a collection of values, right, where we have at least this one, and then maybe more than. This is what the greater than is used for. So we can use this to just, from any other implementation of the from lecture function, right, sort of concatenate the return values. So long as everybody defines a return value to be typed like this, or including other things, right? Then the final from lecture return type would be the accumulation of all of the from lecture error types, right? They will be unified into the same variant. And that's amazing. It makes from amazing error handling, because no matter how deep into your code base, if at any point you have a result that has an error that uses one of these things, that error will be just magically bubbled up all the way for you to handle. it makes for some really neat error handling at the edges, at the top of your application. I really miss that. I think that this error crate is amazing. It does a really good job at helping me out structure my errors in a way that I can say, okay, these errors are actually from the parser itself at the top level. There may be more errors, and so I can compose them in certain ways. It has tools for saying, I think it's not being shown here. Tools for saying, yeah, here's an error. It actually comes from this particular instance of an error. And then you also have transparent, right? To be able to say, well, there will be another error that comes from a different definition of an error that uses the same crate. So in some way, you define your hierarchy of errors with this crate and these macro annotations, right? And then when you get out, it's sort of a nice way of bubbling things up. But coming from OCaml, it's like not quite there. It's really not what I wanted. It's just yeah, it's okay. What did we do here? Oh yeah, okay. So we'll just now drop an error here, and I think we can just get something from, yeah, I think an unknown will be okay. And we'll tag this by saying, oops, something went wrong, right? Cool, so that will be your first error. Now we can actually use that error type here. And I am gonna call it parser error, so we can bring it into scope somewhere else. Parse error actually, into scope somewhere else. So the next thing we wanna do is actually add a diagnostic structure somewhere. And we said we will have a separate module for that, so I will add that. Create diagnostic, right? We'll bring everything in there. So diagnostic, we want to do an enum most likely. And here we will have different diagnostics. I don't really know what the diagnostics will be right now, but we definitely want to be able to add things here like, let's say, invalid function call, right? Or things like that. This may be a really large enum at some point. I don't know. I'm also not saying that this is the right way of building a language in Rust. I'm just playing around with the language right now, trying to find different ways of doing things, right? So I'm gonna give myself a little leeway more. There you go. Cool. And I actually need to have a parameter here, lecture. Excellent. So that's where the lecture comes from. Okay, I'm just going to qualify that. I think that'll be fine. All right, so let's assume after we have this in place, there's some things that we will still use, like the parse error, the parse result, and the diagnostic. But this straight here, right? Will we use it, and how would we use it, right? So let's say we have parse, and the first thing we want to get is actually a module, right? And to get a module, we want to get items. And to get an item, we will want to grab the lecture, right? And do something with that. So here, we would do something like module item, right? No, I don't think that'll work, will it? Because we implement the trait. If we implemented the trait, right, for a module, no, I think it would, because we don't have a self here, so this will actually be available through the module, the struct itself, rather than an instance of the struct. So from lecture, right, and then we'll do mute lecture just to pass that there. Okay, so let's see what the compiler says. Of course, we don't have a function, right? Get rid of that for a second. We don't have this just yet. Get rid of that for a second. So my guess is that we should expect, okay. Doesn't have a size known at compile time. Require a bound in parse result. So this will want to restrict self to sized. I wonder if we can do that at the parse, the trade level instead. I don't know. All right, following the compiler here. Got some more errors actually. Cool. The variant, right? Module item from lecture is this function from lecture is not associated with module item as a struct, right? I think, yeah, the help says, items from trades can only be used if the trade is implemented, right? Which is a sort of a nudge. Maybe you need to implement the trade for this thing, which is good. And of course, this will continue to bug us until we have a break in that loop. This looks fine. Okay, so continuing with this, we would need to implement, right, the actual from lecture function for this particular struct. And I actually would really like to keep those things separate. But let's see if we can make it work first. Parser for, yeah. I would like to keep them separate to avoid having like a cycle between the modules, right? Because right now this whole trait, depending on the errors and so on, is actually defined within the parser, and the parser depends on parse tree. And if I implement it in here, then parse tree will also depend on the parser. So let's see if we can get this working, and then we'll break that cycle. Right. So this will be like the scope. We're gonna import that. Sure. And then we're gonna implement. Oh, what? Do I need to actually provide a default implementation here? To do. Whoa, didn't I implement parse? My bad. Import that thing. Split import. Oh my god, what is this doing? Unmerge use? There you go. Parser. Cool. I was expecting this to show me and ask me if I want to implement the default members, which now it does. But I don't know if this is because I implemented a default there or not. So we'll go back, we'll save everything, and we'll try again. Yeah, that worked. Okay, cool. That's fine with me. It's a lot of expanded things here that I don't really like. Yeah, I want to do that. I like that better. And I think in this case, I don't need to be explicit about the bound, because it should know what my struct looks like. Okay, so then I should be able to call this, right, from here. And if I keep going, right, like in this function, I will have the lecture. I wouldn't know about anything else that we just parsed. I would just only have the lecture, right? And I will be able to say, okay, I'm gonna had a typo there. I'm gonna parse the next thing, right? So one module item can be one of these things, right? I think I'm gonna have to pick. So right now we only have value declarations, right? So maybe we can just say value declaration, right? And then from lecture, and then just pass the lecture in there and return that. In the future, if we have different things from lecture, if we have different things that we can do in the module, like more things in this enum, then the logic of this function wouldn't have to change, right? Yeah, generate from lecture function. Nope, that's not what we wanted. We want to implement. There you go. That's the one. Nope, not even that one. Well, I mean, that's close enough. 4, right? And then we'll get that. Excellent. Yay. And this will be pretty similar, except that we here will want to parse individual things, right? So we'll do something like let name, right? And we'll say ID from lecture, right? We want to make sure that we get an ID from here, but not any ID. We want to get the actual thing. Ooh, I feel like this parse result is going to get in the way. So I guess it would be very, very nice to be able to just say, hey, this is the thing I'm trying to parse, right? Get it from the lecture, right? Pass in the lecture and have an operator like the question mark, right? To just give me back the thing I want, right? If there are no diagnostics. If there are some diagnostics, then we just want to sort of add those together, right? And bail. We'll have to find out what the right ergonomics are here. Right now, this will definitely not be what we want, right? Because here we would essentially get a parse result, right? And as we saw before, this looks like that, where we have a value and we have a diagnostics, right? Vector. If we were to return something more of a tuple, for example, where we do have a name and then diagnostics here, right? Then if we had to parse a couple of things, then yes, we could continue going forward and then eventually concatenate all diagnostics, right? But that feels like something very error prone. Like we can reorder diagnostics accidentally, right? And we can also ignore some of them. And we would like not to have to do that. Yeah, but I think it would be, at least we'll be able to, no, we can pattern match as well here with parse results, right? And just do that. Oh, it's not called name, it's called value. Okay, I like that less somehow. So what would happen if we just do an actual tuple, right? Ooh, converted to name struct? What does this do? Oh, cool. Yeah, you know what? I think it might be a better idea to just say, well, we're gonna do this, right? We're going to just remove the parse result entirely, right? And just use the little tuple for the types. I mean, the type will be anyways enforced, right? By the trait. So it's not like anyone can just say, well, I'm going to return something other than that. And it does make it a little more explicit that we have a diagnostics there. Like if I'm parsing on one specific thing, maybe at this point, this shows me all of the information I need to have, right? To be able to actually build this little parser that will handle just one thing. We'll see. So I'm going to qualify diagnostics here. No, that's not what I wanted. I wanted to import diagnostics. Ooh. I don't have that anymore. Cool. So now this is just complaining that we don't have a from lecture on ID, which is fine. So if we go to ID, we can begin by implementing parse for it, right? Cool. A lot of boilerplate code. It's fine. Can remove that where. Okay. So, what do we do now? Now we actually need to get an ID. If we don't get an ID, then we can return some diagnostics, right? So we have a lecture, and our lecture will give us back a token, but we expect that token to be of a specific kind. So the easiest thing we can do at this point is just say lecture.next, right? And then here we'll get a token. So I'll open the lecture on the right here so we see, and we'll have a token called ID that will have a string inside, which is kind of great, right? So we do token ID, and this will be the ID. And if everything's good here, we can just say, all right, I'm gonna return the ID, right? So I'll just reconstruct my ID with the token string inside. And for the second part of the tuple, we're just gonna pass in an empty vector because nothing went wrong. That's fine. Now, whatever else you return, right, we will actually, and okay, we have a problem here. Because we can't always return, right, the thing that we're parsing. Then this will have to become an option, right? So you can say, well, yeah, we found something. This is some ID. Amazing. Or we didn't find anything. That's a none. So maybe we just want to push the diagnostics to the right of the result. I don't know. Maybe it would make more sense to not have to thread diagnostics like this, but to rather pass in something, right, that can collect diagnostics. So as you go along, you can just chug and say, well, here's a diagnostic, things are good, things are bad. Just like we have the lecture, right? It could be an input to this, like, I don't know, diagnostics handler, right? So then, oh, we don't have anything good. Diagnostic handler, I'm gonna call you. I'm gonna say report, and then we actually add a diagnostic struct here that says, oh, you know, this in the current lecture information, and we can just maybe even drop the lecture as part of report, right? Just so that it gets read correctly and we get the right file and column name, a column number, and line number, right? But then include some more information by using a diagnostic enum. Now the question is, if we did something like that, what would happen afterwards, right? Let's say we do have this. What do we return from this function? I guess we will have a parse error, right? So error, parse error. And this will be something like unrecoverable parse error. Or would this actually be the diagnostic? Unrecoverable parse error. Because we want to be able to say, I guess the lecture right now doesn't really have any modes where it could fail, right? Like everything we do is just call next, and eventually we'll just say none, and that'll be fine, right? What else could fail from the parser itself? Maybe that's a better question to ask, right? If you always give me some sources that I can push into a lecture, and I know that there's nothing here that should fail, then maybe we can use the right-hand side of the result, right, as a collection of diagnostics, right? Let's see. When I was working on Caramel, the parser for new syntax, how did I do this? Got a bunch of errors here. Yeah, I don't think I did diagnostics. I did. Huh. And this is just a mutable list, and I'm just adding to that list. Okay. So am I actually calling this somewhere? Nope. Classic. Nowhere whatsoever. Okay, so that was not what I was expecting. Got any ideas? Gonna have a glass of water. Okay. So let's say we do that, right? The parser actually has a collection of diagnostics, and we are going to pass in. Oh, I just saw your message, Gafa. Yeah, that would make sense. I guess the question would be, how can we make sure the diagnostics can be collected and passed around without necessarily breaking the execution of the program, right? Because if it is some sort of error, then the moment you do a question mark there, then you're done, right? You cannot keep doing that. It will just break the flow. So I kind of want a version of result that has sort of two channels, but I guess, or maybe three channels. And in one channel, I just have this diagnostics information, right? Yeah, you know what? I think right now we can go by saying either you get something back or you get a parser error. And as you're saying, GAFA, we can just say, well, we're going to use the diagnostics in here, right? For some things. So diagnostic. And I wonder how we will turn that diagnostic into a string. We can worry about that later. Yeah. What was the syntax for this? We want to do 0, and this will actually complain because we have not implemented format or display. Yeah, perfect. Yes. We need debug for this? No, I don't want debug. Oh, I guess we'll need debug for because of that. Cool, sure, whatever. We'll do that, and we also will want to do implement display actually, right? Actually, we don't want to do that right now. All right, whatever. I'm just gonna drop diagnostic right here. We are not really going to do anything more than this, right? I think 0. No, sorry. We do dot 0, and maybe like that. The hell? Yeah, I think it's gonna get a little messy. How do we do expected? Found. Is it just 0? And then like that? Excellent. That works. Cool. So either you get the self or you get a parsed error, right? Which is fine. And then we will still just have this vector, and it's a vector parse error now, which is fine. I guess some of the parse errors will be diagnostics, so we can just collect them there, right? So if we were to do parse error, oh my god, it already knows everything. Brilliant. So if it is that, that's great. If we do have any other error that is not a parse error, right? A diagnostic that we want to collect and continue, then we'll do something else. So for the time being, we'll just panic and say, oh no. Cool. Yes, this will continue to say it's unreachable because we haven't taught the Lexer how to know when it's done. There's nothing else to do. All right. Again, we're just sort of exploring what would it be like to have a parsing trait, right, for doing this. So each one of the data structure gets defined how it's going to be parsed, rather than having the typical like bunch of recursive functions, right, defined within the same module or struct. We'll see how that works out. And if it doesn't, that's fine, because we can always just grab the entire function right here and just move that around and then rename it. It's gonna be a pain in the ass, but we'll be fine. Okay, so we wanna do the self thing, right? There, that's good. Now we want to have a parse error that says expected ID, right? So I guess unexpected symbol found, right? And we can say expected, and I wonder how we can phrase this nicely in data, right? Like token ID, some ID, found token. I think that will be fine for now. Cool. So now we just need to add this variant, right? And I don't actually have the code action for that anywhere. Okay, so then this will be a diagnostic, right? And then we'll do parser. Diagnostic. Wait, I'm missing something there. Okay, so now syntax-wise, it's okay. We will have to deal with the none case as well. So I guess we could just always expect a token, right? Because if we don't have anything here, then we definitely don't want to continue, right? It's like, all right, there's nothing more to do. We just return saying we're done. Which, that's also another good question, right? Like seen in some other similar or parsers I've done, right? For example, I think in Caramel was it that I did this. There is a main loop, right? And this thing is sort of always returning a t. It doesn't wrap this in a result or anything, right? And then at some point when we're done on parse patterns, right? At some point, right, we have a parse error, which is end of file. And sure, this works, right? Because then I get a piece of data that tells me I am done reading this file. There's nothing more to be read, right? We can just grab that accumulator of things we parsed and return it, and it'll be fine. But I don't like it. It feels super hacky, right? Because it's not really an error that we're done parsing the file. The error would be we were in the middle of something and that happened. Um, but here we don't actually have enough information to know when we were parsing. I mean, we know we're parsing a structure item, right? But it's not like we're checking before every structure item saying, hey, is there anything left, right, to parse? But then again, you don't want to do that everywhere. You want to be able to do that sort of once. Have the lecturer, right, say to the parser, I am done, right? So in some way, maybe even the parser needs to be the one calling the lecturer directly, right? So when you have an individual data structure, like an ID, right, is saying, oh, I would like the next token, pretty please. Then this thing is like, no, we're done, right? Parsing is finished. Because the parser is actually calling the lecturer for you and checking that there is something to be called. Sorry, something to be parsed, right? I don't know. Do not know how this will look like as this language continues to evolve on scale. For the time being, I'm just gonna drop a diagnostic there. And I'm kind of mad that there is no code action for this. I am not much of a like auto-completion sort of person, but I've gotten pretty used to Rust's auto-completion in NeoVim. God damn it. So we have a token there, and we have a token here. And I'm kind of mad that I like it so much. Important. Because I know it doesn't work for all the languages. It's not always the same key bindings or whatever. And I could put the time to make it work exactly the same. But then again, typing code is not the bottleneck, right? It's just making sure we're typing the right code. Okay, so we have that thing here. Everything works fine. Problem is the next returns an option. So what do? Every time we call next, we we check, oh, if this is none, then return an error saying we're done parsing. Like this is the ID, but we'll have to do the exact same thing, right? Everywhere else. I don't like that. I would like something like next or finish, right? So I can question mark it and let the lecturer sort of bubble up some value saying we're done here. Maybe this is why it's easier to just have all the functions in the same spot. Because then I will be within the parser already, so I'll be able to just, flick a switch and say we're good, we're done here, nothing more to be parsed. Okay, so let's implement this and see what that looks. We are making a lot of, I was gonna say decisions, but compromises and experiments. Public function next or finish, right? Yeah, and this will take a mutable self, right? And it will return a result of an option. I guess a token, right? Or a parser error. And we can just check, right? Match like next. And if this is some token, then we just return OK token. I think we need Ooh, there you go. And if it's none, then we know that we're done. So error, parse error, end of file. Are these fat? Yeah, these are fat arrows. Sure, we can do that. That's fine. Why would you want that? I don't know. I don't think that was the problem though. Oh, this is self. What else? You think so? Yeah. I lost my powers. Oh, I miss other people in the chat. Hello there, Ivuka. Good to see you. Cool. Yeah, we don't have parser here. It's not imported. Let's actually do that. Use create parser, parse error. And I think maybe we even want to move this into an error module. I like that. I like that better. Sorry. And source error rs. And then we can just say parse error will be that. So that moves to the right. We will need though to bring this error library as well. Right, and I'm gonna have to open up or sort of mark this module as part of the build. Use create error, and we'll bring everything from there. Cool. We don't use diagnostics here, not directly, but we use it here. What is the thing here? What? Look, this is insane. It says the enum import parser is defined here and refers to the enum parser, which is this cannot be the same message, right? Like I would expect this message to be in one single file rather than split across files. That's kind of cool. Let's see what the build system says. Oof. Okay, so definitely a couple of errors there. Let's go into error, and we're gonna end the new one saying end the file. We reached the end of the file. Really don't like having to use these errors for flow control, but it'll do. Cool. Okay, so now that we have the error there, right, the lecture should compile. Oh, right, we're not dealing with a token here. We're dealing with a lecture of a token, and the token is what we own, but the lecture itself comes from the logos library. Fuck, we're gonna have to wrap that then. Okay. I think this is where we get our pickable lecture, right? We don't need the whole thing. We can just wrap the lecture in the struct, right? So I'll do two things. First, I'm gonna actually move the tokens outside into a token file. I think that will be fine. And we're gonna remove that from there, right? We'll keep the tests and so on. But our old lecture, right, will now import the tokens. And we will define a new lecture. Obstruct lecture, actually, we're gonna call it, yeah, I think we can just call it lecture. That's fine. Maybe not, because we will have to bring the other lecture from the other side. Inside here, we want to have an inner lecture. There will be lecture lifetime, right? One second. Just need to double check one thing. Cool, we're back. Right. No, actually, it's called parse error, rather than parser error. That may be confusing though. No, no worries, no worries. Good to see you around here, Tom. How are things? All good? So we want to have a logos lecture here, right? And I think we actually want a reference to that. I forget how I did that before. No, we just pass the lifetime of the source into the lecture that comes from logos. And then the second argument is going to be our token type. That looks fine. So then we have the source, and then we have the token. And this would be also called source. Cool. So the nice thing about this is that now we can actually implement a lot of custom behavior on top of the lecture, right? We can do our sort of next or end, right? So in some way we are, I guess that end of file could be a token, right? If we don't have anything else, we just pump that token out. How does logos deal with that? Good to see you too. Let's see. Let's just go into logos and just search for end of file. Of course, no, nothing there. Nope. Go back to the issues. I'm gonna search for EOF, right? End of file. Oh, we have an end. This is also fairly old. Okay, no errors regarding the end, so maybe it will just work, which is great. Cool. Okay, so now here we can implement our next function, right? So public next, and this will be mutable, right? Self, and it will return a result of a token or a parse error, right? But if we now have a token that represents the end of the file, right? Then I guess we can always return a token. And at some point it will just be in the file. So why are we even doing all this stuff? Like, just backtracking a little bit. We wanted to build a trait, right? That different pieces of the parse tree can implement to describe how they will be parsed. So when you grab the entire language and you grab a specific part of it, so parse tree, for example, you want to grab a module item and you want to parse from whatever data source, right, into tokens, and from those tokens into a module item, you can just look for the implementation of this trait, right, for that particular data structure. And in here, this function will decide, okay, given a lecture, if you give me a lecture, and now this will just be our own lecture, right? So no need for any of that. If you give me a lecture, then this is how I will parse myself. and I will become either a module item or some parsing error because I failed to find all the things required, right, for a module item. Um, in that sense, if you keep digging, right, the different data structures sort of guide the parsing itself. Module items right now are only value declarations. So we can say value declaration, how would you parse yourself from a lecture? And then we can jump into the same implementation for a different data type, right? Value declaration right now requires a name and a value, right? You're declaring a value and just giving it a name. I guess it could also be binding, but I think by declaration these days we sort of understand that there will be a name that we use to refer to the thing that we're declaring. So in here, same thing, right? You receive a lecture, and then you either become a value declaration or you return a type error. And in this case, we want to do the exact same thing for the ID, the name. So all names are valid identifiers, right? That's what we mean by ID. And then we ask the ID data type, hey, how do you parse yourself, or could you parse yourself from this lecture, right? And then if you go to that trait, you find that implementation. But what happened here? What happened was that we were trying to figure out how to nicely, idiomatically deal with sort of running out of tokens, right? What would happen when you try to parse an identifier and you really, really, really want a token that it's an identifier, right? And then you find something else. Or worse, you find no tokens, right? So we thought maybe if we wrap the lecture, because right now the next function sometimes returns your token, sometimes not, depending whether there are tokens left, which means every one of these parser functions, right, which are pretty tiny now but will grow, will have to say, okay, give me the next token, right? If there is no next token, then they'll have to handle the case of no token existing and say, damn it, okay, I'm just going to return some error, right? Parse error, like end of file or something like that, right? Which makes the entire parser super verbose. Because we know that if you're trying to parse any of these things and you run out of things to parse, that's the end. We don't want to implement this over and over and over in all of these cases. So we thought we're going to wrap this into a new function, right? Next or finished. That we could then use the question mark on. And the nice thing about the question mark in Rust is that if the value this returns is an OK, the program continues. And the OK value can be used directly. But if it's not an OK, if it's an error, then this part of the program doesn't execute, right? It just short circuits and comes back, returns, which is essentially the same thing as what we had before, where we said non-return error, right? End of file. But automatic, which is a little better. Now, while we were doing that, we discovered that, we could get the lecture to actually always return a token, right? So when we do self next, if this thing is like none, then we can just say token end of file. Else, we just return whatever token we have there. And yes, there are more idiomatic ways of writing this. I think no, not a diff let. I think we can do get or else. Okay, it's definitely not liking what I'm writing. So I'll leave it at that. And this will be source. I am introducing a lifetime. Okay, I need to do that. Cool. So we are not using that. Did that make some sense? So by always returning a token, right? Even if it's in the file, which is the only token we could get when we're out of tokens, because that was the end of the file, right? Then we avoid all the process of handling that explicitly. but we still get all the benefit because the end of file will most likely not be a token you will handle in any of your individual tiny parsers, right? And if you did, then you are cursed. You should not be building this with me. Or even by yourself, right? Sounds like a terrible idea. Unless your program requires, the end of a file to mean something, like the end of a module, for example. All right. So far, so good. We will not need this particular error because now we have a token that represents that. Now I'm confused why all of these things are breaking. And I think it's because I didn't add the mode token here. Cool, so that should be fixed then. What? Unresolved item import token is defined here? What do you mean unresolved item? Token. It's a public enum token right there. Wait. Right. Unnecessary braces around block return value. Okay. I can live with that. This really exploded in complexity compared to the last stream. He was like, oh, we're doing nothing, just playing around with the tokenizer. What braces? Okay, so it's possible that I misread the docs here. And by possible, I mean definitely. So let's look for that end. I think we might not have that there. This is where we were. Oh, so this is passing a test. Is it still passing that test? Let's go to the current version of this. No, why would you go away? Right. Tests. Source. No. Nothing here. Code gen. Nope. internal, cogen, derive, tests. Okay, so we don't actually have a token for this. No! That sucks. Rust, logos, handle, end of file. Yeah, actually I think we're gonna struggle with this there. Let's go back to the official docs. Nothing, no mention whatsoever on this. I think the easiest way would be to just use that none, right? But then we run into the same problem we had before. Bright side, we still get to use the question mark operator. Downside, we have to add an error here for end of file. Fine, we'll do that. Error, parse error, end of file, and then OK token. So, import. No, why do you do that? That's horrible. Error, parse error. There you go. Cool. Slowly getting there. We don't need the token with end anymore, right? I can say that. Cool. A little better every time. Now the parser is now going to get a logos lecture. It's just going to get a lecture. And the lecture is going to come from here. Cool. Parser, parse error. We're importing this in the wrong spot. Token. No, token looks fine. Parse tree, maybe. Yes. And he did this horrible, horrible thing. Oh my god. Unmerge use, thank you. Token, but also we need just a lecture. Import. Cool, so now we will do lecture next, question mark. Finally. And that should have worked. So let's see what happens when we test. Great, we went through that just fine. Now we have a little error with the kind of parse error we're returning because we have not imported this. And after we do, more errors, yay. Okay, so line 29, right, that makes sense. So we're not finished building the parser for value declarations. We parse the IDs, nothing else, right? So at the end of the day, we do want to be able to say value declaration or just self, right? Name, value, and this would be the okay thing that we return. But we don't have a value yet, right? And I guess also our parser is broken here, 25. Cool, so we'll do lecture from source. What was it? Yeah, that'll do. Go back to lecture. We'll do pub function from source, and then we'll take a reference to the source. I think we can take a string, and we'll return ourselves. But to do that, we need to build a lecture, and to build that lecture, we are actually going to use token lecture source. And I think we'll need to do logos here, so we get access to the trait. Yes, that worked. Compile, move on. Excellent. Holy crap, so much plumbing we need to do here. Yeah, so we don't actually need to give it that, and we probably don't even need to declare it as mutable. What? You just told me not to, did it? Yeah, consider removing that. Expected string. Oh, I have misread that. So if you give me a string, right, that lives as long as the lecture will live, then the lecture will live as long as the string lives. Great, now we're almost done. What else we do? Right, we don't have yet a value, right, in our parser here. No, wait. Parse tree here. We don't have value. We'll need to do that for the expression. And then after that, we have a small error. Yes, line 42, same thing, right? Here we sort of want to just say like, okay, we get a value declaration, and we're just gonna wrap that in value declaration. Not the struct, but the module item constructor. And this will be okay. Right, so that leaves us with just one thing, the value. So right now, I'm just gonna say the values are optional, right? Just so we can get away with setting that to none, compiling that, running the tests, and having to fix a bunch of other stuff. Why don't you like this? I guess you cannot borrow as mutable something that already is borrowed and mutable. Did we break the trait? No, the trait looks good, right? You sure about this, compiler? This does not sound like a good idea to me. Fine, I'll just make it public there. All right. Whew. Tests are passing again. Yay. We have a couple of functions that we are not using that I really expected us to be using. But I guess we're not really using parse, right? Yet. Okay, so before we continue adding anything else, let's start writing a couple small tests, right? For the parse module, where we will actually exercise the little bit of code we've written, see if it makes sense, right? See how ergonomic it is to use. And I also think that at some point, if we get a parser error in the file, then we will just break from that loop. There you go. So we should have even less warnings. Nope, more warnings. Okay. Error, I'm gonna drop that debug. Cool. Can't. I need that debug, but if I put the debug, then I get warnings and I'm not using the code. No. Okay, so this is never constructed. Okay, so first test. What do we test? I guess we want to test that an empty file, right, will become a module with no items, right? I think that's reasonable. Parse empty module. Okay, so our parser, right? We invoke this by saying, I have a string and I have a module name and I want you to do stuff. So let parser, and we'll do from string, and we'll say test module, and the contents will just be an empty string. And just for my own peace of mind, I'm actually gonna put this both as references to strings. I'm just gonna have to write this a lot. In reality, we don't want to actually copy and own that string. We just want to say, oh, the parser is going to live as long as that string lives, so that we don't have to sort of unnecessarily duplicate data. Cool. Now we have that. We've got a parser, right? And then we want to get a module back. So we'll do parser.parse. And this should give us a module, methinks. So we can do assert, I believe it was assert match, and we'll do module, and then here we'll do a module, right, with name, and we'll do an ID of what, and items is going to be empty. Now we're just trying to match on something, right, so that the compiler will fail. Assert equals, forget, let's check. Okay, of course I did something. Yeah, I'm using snapshots. Why would I do that to myself? That's not what I wanted to do. Hey, look at that. So the way I did the error handling before on lore is that when you parse, you get a parse error, and this thing, right, has a bunch of things like source code and label and so on, and it also has a syntax error. So every one of these sub functions actually returns syntax error. They are defined here very nicely. Name is missing. This relation expects a subject to be a name and stuff like that. And I think this is due to Miet. We will have a look. I think that if we get a couple of tests up and running that check that what we have sort of works, after we finish the support for declarations that are values bound to literals, right, like numbers and strings, then we can just take a pause, add Miet for error reporting just to see what that will look like, right? And I think that will be enough for today. I reckon that it will take another 40 minutes to do all that. So that will be a 3 hours stream. Oh shit, 10:25 over here already. Yeah. So I'll be able to go to bed after that, knowing that I've done something productive today. Other than work, right? Okay, just give me a second. Okay, so we want to do matching here, right? I'm pretty sure that Rust actually has an assert match. that we can use. Matches. What? Oh, nice. This doesn't. That's unreachable. This pattern has two fields. I think maybe it's the other way around. No. Let's read. Matches in standard library. Returns whether a given expression matches any of the given patterns. Oh. You can assert on that, which is what we're trying to do. So maybe we'll be a little more granular than just dropping everything there. And we'll say, all right, we'll expect the module name to be that. And we'll expect the module items, right, to be an empty list. Okay, we're gonna have to derive a couple of things. That's fine. Debug, I think, is the easiest one for us to drop everywhere. We want to have that. Let's go back to the running of the tests. And cool. We also want to implement equality here for these two things to be matched one against the other. Why though? Operation double equals cannot be applied to module item. Is that because we don't have partial apply here? The error certainly changed. Partial EQ. Great. Our test is running. Things are failing. This is good. This is very bueno. Okay, so we know that this should be a test module, right? But just so that we can make this fail one more time, we're gonna send the length should be 1. Perfect. So the length that we have really is 0. Amazing. We can parse empty modules. Folks, we can parse empty modules. Next step is executing them. Fastest programming language in the Nordics. All right, so next step, we want to parse a program, parse a module with declarations. I guess there'll be tons of different ways of testing this, right? Different combinations of declarations. At some point, we might even want to experiment a little bit with fuzzing, right? The art and science of generating programs, right? That we can push through our parser to make sure that our parser works for all of the possible valid combinations of tokens that we can generate, or non-valid, right? Just to find those spots where the parser will just blow up. If you send, for example, 71,000 equals, then it breaks. Anyways, so our tiny program here will just say, I guess, name, and this will be qlang, blank. And that's the name of the language. It's called Q because of the Q continuum. in Star Trek. These folk are super powerful. Not because the language will be super powerful, but I think the requisites that we had originally for building language, which are come all the way back to this tweet from earlier this year, I think this would be a pretty insane language. So we'll see what we can do to mush them, all the requirements together, and make something happen. That's sort of where we are now. All right, so run again. This will fail, naturally. We have one item instead of 0. That's pretty good, right? Let's put one item there. You see this? We have one module item, which is a value declaration. And this value declaration actually has a name, which is the name we have here, right? And then it sort of ignores everything else and we just continue. Interesting. Why does it do that? So if we sort of print out the tokens as they come, right? Just debug, right? The token. And we just run the parse tests. Then you see that when we're running this test, we see first token is the name, then we have equal, and then we have the literal string for QLang, right? And then we sort of panic because we're failing the test. What I don't understand is why, I guess, on every other iteration of the loop, right, we'll just call the same parser again, which is this one. And this will just go deep down until from the value declaration to the actual ID, and from the ID it will sort of just do that. Call next, right? And eventually we will be done. What I'm confused is why don't we see this thing? Because I guess that if the only thing that we really know the parts right now is the ID bit, right? Then eventually we will re-enter this function and we'll do next, and we will not find an ID. We would find equals, and this is clearly happening because we are seeing that printed out, right? Somebody is calling this next function that is debugging this token, right? Now the question is, who the hell is doing that? Or where the hell are we doing that? And why isn't that token pushed through? Wait. My bad. So I'm gonna turn this diagnostics into something that's saved inside the actual parser, right? So we can do self.diagnostics push. Yes, I'm gonna import it. No, don't generate. Oh my god, so much stuff. I just wanna import it. There you go. Cool. We're gonna turn this into a mutable self that we consume, right? And then in our tests, what we will wanna see is that when we not just parse an empty module and things are good, but also we want to assert that there are no diagnostics, right? Diagnostics len is 0, right? So now if we do that here, I think the first test is going to pass, the second one is going to fail. And I also think that this, unfortunately, should not be a consuming function. this should be a reference. So you call parse, and we go through the whole thing, and then maybe we want a separate data structure that represents the final result of the parsing and includes all these things. But right now, we'll just do that. And I think here we'll have to do clone. Okay, so as predicted, first one works fine, right? It's okay. Second one failed, right? We definitely have. I'm sorry. I guess we failed in a different place. I'm gonna put this up a little bit here. Parse module. And we have 2 diagnostics. Amazing. This is excellent. So now we can just sort of assert equals and do vec like that. And we will see what the diagnostics are as soon as we actually gave the right equality traits. Cool. We have that there. So far, so good. I'm gonna swap those. Actually, I'm gonna put the right number. And there you go. Unexpected symbol found, expected an ID, right? Found equal. Cool. So I think we have most of what we need right now in place to start slowly debugging, adding small tests, right, for different syntactic constructs, right? Creating the parser for those things, right? And, actually parsing them. So let's fix this one. So we get that in place. And we need to go to here, parse tree. So first we will get the ID from lecture. I think then we actually want to expect an equals, right? So we can just say expect token equal. And if this is okay, then that's fine, right? It returns a unit. But if it's not, then it blows up. And then we can sort of get the actual string, right? So value. And here, I think we'll just go for this. Let's say value is going to be an expression from lecture. And then we will pass in the lecture. Now I expect this to fail because we should have consumed. No, actually, that's not why it fails. Yet. Cool. So expressions can be literal and I wonder if it makes sense to just do like literal string right now. Yeah, that'll do. So we can do lecture next, right? And then if we get a token of literal string, right? Then we'll actually return okay, expression, literal string, right? And else we can do diagnostic. Unexpected symbol found, we can say expected expression. And we can just say this is what we found. Cool. So going back to error, diagnostics, expected expression. Save everything. What is the matter? Expected one of okay operator. Okay, I'm missing a comma at the end. Oof. Missing expected. No, I don't want an expected. I just want a found. Cool. So now we can add a new method to our brand new lecture, right? Expected. And here we will have an expected token. So we will return a result of, okay, we found that exact token and that's fine. Or a parse error, right? I wonder how we will make this nice later to be able to say, oh, we expected an equals, but instead you drop in a question mark, right? Like, did you mean this or that, right? That's not something we have right now. Okay. So I'll put this below the next, and I think we can do self.next, right? And if we get a token, I mean, if next is expected, then we return okay. Else, we'll just return error, and we'll say parse error unexpected token. And what's the overlap, right, between these parse errors and the diagnostics? Again, I feel like I need to do some digging. You got any resources that you dig through to understand like the nuances between a parsing error, right, and a diagnostic? Okay. So for the time being, I'm gonna say we want to return an error, and the error is going to be a diagnostic here. So unexpected symbol found. So we will definitely want to see like a symbol, right, or token. Say found. I wonder, I forget what the exact terminology is that I used in Caramel for this. Let's look at the test. 74. Ooh. Wait, what? We have 0 diagnostics now? No, that sounds wrong. We did not fix the parser. Did we? Ah, guess we did. Guess we have done it. So we just want to drop this thing right in there. Actually, this thing. And of course, some small changes later. What do you mean? Okay, I'm missing that parenthesis. I'm missing that parenthesis. Can I find function? I guess this will be a token. No. Cannot be a token. It's got to be an expression, right? Use literal syntax instead. Am I not using that? I feel like I am. Module item. I think that was the problem. Cool. Boom. Amazing. Cool. So let's run everything. Let's see, everything's still passing. Oh, I gotta love it when Rust has so many tests, but they run so fast, and you like don't even care. Run him in a loop. Cool. So that said, it would be pretty awesome. I'm gonna mark our beginner parser as X, right? It would be pretty awesome if we actually had an executable. Now we don't need to be fancy about this. I think we'll just take the first argument and just try to read that thing, right? So in here, we will just try to read whatever file you give us. And then we'll try to parse that. And if we have any diagnostics, we will just complain loudly, right? Okay, so again, we need to be able to get the arguments. And unfortunately, I got used to using struct_opt. In case you don't know that one, struct_opt. It's a beautiful library for defining sort of command lines from data structures, which is great. But it's a little overkill for what we want to do right now. We really just want to get... No, but I really don't want to. I don't want to bring another crate for this. Args in standard env args. We can do that. This implements an iterator. Okay. Sounds fair to me. So we're just gonna grab all the files. Or file in, what is this? Standard env args, right? And I think we would want to slice this, so we drop the first one. But for each one of those, we want to build a parser, right? And do parser dot from file, from sources. What do we do here? From string. All right, let's just do from file. So we'll try to read that, right? And then parse it. And then if we have any diagnostics, we're gonna just spit out something nice or something. So then it will feel a little more like a language, because we'll be able to actually write a little bit of our language in a separate file and then call our binary on that file, right? And see that, oh, we have some problems. You know, we miss a symbol or stuff like that. Yeah, so as in our tests, right, we want to just do parse like that to get something out. And after we call parse, in this case, we don't actually care about whatever we are returning from parsing, right? We just want to call parse so that the parser itself will have all the diagnostic information. Okay. Into iter. Can I turn you into an iterator? Yes, I can. Can I index an iterator? Can I slice an iterator? Rust slice iterator. I think I might be able to do drop, to just drop the first element. But I am turning you into an iterator. Shouldn't you have those things? Rust iterator drop first. skip. Sounds fair. So we will implement in our parser a from file function. And we're just gonna get a file name, right? And return a self. And here we're just gonna do the dumb thing, right? We're gonna grab the file name. And I guess we probably, instead of this, we can probably just get a path. So the module name is going to be the base name of that path, and the source is actually going to be reading that entire path into a string. So we can do stunner fs read to string, and we have a file name here, right? And I think that'll be fine. Source, and we're missing diagnostics, and that's going to be an empty vector because we have nothing yet. And yeah, we will have some troubles if you try to read a path that doesn't exist. So we actually can turn this into a result and return a parser instead, right? So here we will want to do map error and say we got an IO error here, and we'll actually, I think we can just do parser error, IO error. And this will be an error, I presume. They have a nice example of how to do this. Logos me at this error. IO error. Yeah, they have that there. Cool. So this will be an IO error, right? And then we can just say from. I guess this will be transparent actually. Is it transparent? Error transparent. Cool. That's settled there. We can save this here. And of course, we will need to wrap this in an OK. Excellent. So now we just need to do a little bit of path thingies. We're going to import a path. And I think maybe it's called file name. So the file name exists. I'm just gonna unwrap that option, and I think then it will be an OS string, and maybe we can just call toString on that. No, that's not what we want. We want to turn it into a proper string. Okay. String. Does this really mean I need to unwrap again? Jesus. Wait, am I missing something here? I have a module name. What is happening? Replace it with module name. That's exactly what I had before. Okay, I think you're just messing with me. that thing. Right. Path. What do we have here to help? No, you don't want to help? All right. Gotcha. Um, why is the signature parse that? It's not. It's actually just a module, which is great. But, alright, this one. That's the one that needs to change. Okay, cool. That makes sense. We want to actually return an OK at the end. So we'll turn this into a function that returns OK with a unit, right? Or maybe an error if something goes wrong. And what I'm wondering is, how do we actually bubble up our parser into something that can be handled, right? And I know that the library has a way of doing this. I just forget. Yeah, exactly. So normally you end up using anyhow, and at the end of your program, I say normally, that means this is how I've done it before, right? So if I go into lower, there should be a binary here. No, spoilers. This result is coming from Miet result. Screw it. Let's just implement Miet right now. Cargo add Miet. Of course, I don't have cargo add. And the last version I used of Miet was 3. Damn. Okay, let's see if version 4 is out. It is? Or 5? I mean, what are the odds, right? Okay, so 5 is the last one. Cool. So 5.3, we'll be using that one. Sounds great. Let's go into the docs. Oh, it was right there. We could have looked that up instead of trying around. Okay, so how do we do this? You can derive a diagnostic from any standard error type. Great, we've used this error. Plays nicely with Miet. Pretend this is main. This looks great because this is kind of what we want to do, right? We have some library code here. We got some diagnostics, and we want to turn this into something, actually, one level up even, here, right? We got this error, and we want to turn that parse error into something um, that can be a diagnostic. Mildly bad code. Oh, there is a trait in Miet called diagnostic. I had forgotten all about that. Okay, so just going backwards from here, we want to implement this in our main file, right? So we'll just do Miet result, right? I don't know which is the fancy report. My guess is that it will be this one, right? Which we can figure out how to enable later. But all right, so then as long as we use the Miet result, we'll be fine. In our main, that works fine. We have a small error here. The trait Miet diagnostic, perfect. It's not implemented for our error. And this is all just coming together very nicely. This module is screwed. I don't know what happened here. There's definitely something so wrong. So I'm just gonna do self, actually parser, and do okay parser. And I think that should work. It does not. What? I have got to be missing something. Syntax errors. Don't know. We'll deal with that later. Okay, so we want to go into the error, right, and say this will actually be a Miet diagnostic. So now I'm wondering if it makes any sense to have a separate diagnostic thing like that. I could just drop all of those into a parse error, right, and be good. Okay, so let's do that. Use Miet diagnostic. Actually, what happens when we do that? Okay, so our parser needs to cover a little edge case here, right? And unfortunately that means our panic comes back for the time being. Oh no. Or I guess we could turn this into a result as well, right? Parse error. So if we find any other kind of parse error, then we'll just return that. We'll have to do a little bit of change in the tests, but other than that, it would mean that we can call parse, and if we have any error that is not something that we know how to handle, like a diagnostic or an end of file, right? If it's something like, oh, the file we were trying to read just disappeared, then yeah, we can just bail. Whoa, that built? What the hell? Seriously? How? I was not expecting it to build. Cool. Cool. Okay. So we'll just do that for now in the tests. We expect the test to pass. Perfect. Cool. So if we write a tiny, and this will be the first time we write a file, right? In QLang. and we will call it main Q. If we write something here like hello QLang, right? Then we want to be able to do this maybe. Whoo! It's running. It's doing things. Not the things we wanted to do, but it's definitely doing some stuff. All right, so I'll remove those prints so we don't see that. That's fine. Cool. So it's doing nothing right now, which is great. Absolutely fantastic. And what we want to do maybe is to parse there, right? Perfect. So if we do like any other file, then we'll get a diagnostic saying, oh no. Yeah. That happened. And I guess if we go into the right file, but miss something here, like for example, we don't have a value for this, we should see some diagnostic. No, that is not what we wanted. We wanted something different. Why would you do this to us? We trusted you, Q. We should have known better. By the way, this is Q, in case you're wondering. That's the guy. He's a royal pain in the ass. But I think by far one of my favorite characters in Star Trek. Yeah. He came back for Picard, the new series, right? Like the sequel to TNG. I don't know if you can call it a sequel. So you can see John Delancey here, and then you can see John Delancey again, but now, right? Like recently. Jesus, that's a terrible picture. So bad quality. Let's see that one. That's a little better. And he snaps. Kind of like Thanos, and he can make people disappear and go places and change environments and do all sorts of things. I don't know, it's a super powerful, omnipotent being, but he's not just like an individual. He's part of a sort of collective, right? The continuum, where everybody is Q. There is no like, oh, Q1, Q2, Q3, or having separate names. Yeah. Anyways. So, why didn't this report an error? A third. The home. ¿Por qué? We expected that to do something, right? So if you're in the parse tree here and you sort of go expect, right? Then you should see an error saying like, oh, I expected this thing to exist. But I don't know, maybe it doesn't because we haven't written a test for that and we don't know if it will actually fail that way. Parse declaration missing equals. Okay. We do have an error here, line 87. There's two diagnostics, right? And this is good. I mean, it's not exactly what we wanted, right? But it's at least telling us that, yeah, there are some unexpected symbols that are going to be brought up, right? And when I say it's not exactly what we wanted, it's maybe because we sort of restarted the process at some point, right? like parser error. Parse error. Oh my god, why wouldn't the format? Just format already. There you go. Thank you. Expected token equal found error. Oh, token error. Oh, sorry, this is diagnostic. Yeah, I think I'm definitely gonna turn the diagnostic into a parse error. It will make things a lot more straightforward. Cool, so at least we know we have those diagnostics. The question is, when you say parse and then you get a result, then do we actually check? If there are any diagnostics, then we return an error saying, here's the diagnostics, right? With all the stuff there. So if self-diagnostics lang is empty, then we'll just do return error, parse error, diagnostics, and we'll just put the diagnostics there. I think right now we'll have to clone. I have done something to this file. I don't know what it is, but one of the parsers I'm using is definitely not liking it. I will need to derive clone to be able to clone this thing. And I will also need to add to the parse error diagnostic one that is multiple diagnostics. Back of that. So I'm wondering how we're gonna make sure that once we pack everything together, we can still sort of surface it nicely, right? And print it out. We'll see what Miet can do to help us here. Okay, so that looks about right. Cargo test should be okay. It's not. And that's because we need to implement clone for a couple more things. So now this thing needs clone as well. Hopefully it will be clonable. Excellent. This looks a lot better. When you call parse, if there are some errors at the end, then it will just say, hey, these are the errors. I don't know if I want that. It's kind of automatic, but I think maybe I want to manually go through the diagnostics. Yeah, screw it. We'll do that. We'll just pass the self, right? And we'll return a vector of diagnostic. We will see how this changes fare later. Diagnostics. Actually, we'll return a slice. So we don't have to unnecessarily copy that data over and over. Cool. So, all right, how do we use Miat now to go over those diagnostics, right? And and actually get something nice printed on the screen. Because the first thing that we can think of is that, all right, sure, we'll just do like for diag in parser.diagnostics, right, to get all the stuff. And here we'll just do something like debug, right? What's the problem? Mismatch type. What do you mean mismatch type? This is fine. Show the cargo run, right? Main queue. My goodness, there are no diagnostics? What on earth? So hello equals. Okay, so if we do have something wrong here, right? Like, you will say, well, you know, I don't know what to do with this stuff. I'm expecting identifiers, which is great. But if we do have a hello and an equals, then it will happily end. I don't know why. I would expect this. Let's debug that. I would expect the expression from lecture, right? Yeah. If it finds a literal string, then it does that. Else, it just returns a diagnostic as an error, saying expected an expression, found token. Oh, right. Don't like this. What's happening is that when we try to pump another token right out, then we must be getting this over here, right? And unfortunately, the way we're currently handling that is right here, which means the last thing that we're trying to parse doesn't actually make it all the way through. So we drop that. And we don't get to push any diagnostics because we never actually got into that space. And this was the problem we wanted to avoid all along, right? The problem of having to deal with the end of file at every sort of step of the way. So I think what's interesting is that if we do define something else, right, like we should see a diagnostic. Yeah. But if we have nothing more there, then it doesn't quite work. Because this whole thing is just disappearing into the void. All right, so definitely there are some changes that we need to make here to be able to handle better. Yeah, I can try that. So we get the question mark is an error here, right? Because we don't have a token for that. It doesn't match anything. And then once we get that error, then we just continue by trying to parse the next declaration. And so it says, well, unexpected a symbol, right? I expected an identifier, but instead you got me this error, which is the other token that we don't know how to parse. And if we do Q, then you will have an error first, and then another error saying that you were expecting. No, I think you will just have one error. Yeah. So the first error is this token, right? We couldn't find it. Ah. Q. No worries. I mean, there's quite a few ways we could try to fix this, right? In the lecture itself, we could keep track of the tokens that we are consuming, right? As we go consuming them. So if at any point we find an end of file, right? No, don't quite like that. Really, what we would like to have is just an end of file here, right? If we have an end of file at this spot, then we'd be able to say, well, we were expecting a literal string, but instead found end of file, right? And then we can use that information to craft a nice message and say, hey, your file is incomplete. You're missing this sort of expression there, here or there. Okay, so I'll mark our executable here as done. We have definitely done some work on diagnostics. It's not perfect, but it's something, right? We have play around with diagnostics. We have definitely explored what would it be like to have a parsing trait, right? Where every different part of the AST defines on its own how to consume things from a lecture, right? And turn itself into a piece of the AST. And I think so far it looks fine. Like I can see how this will help split up what otherwise would be a massive file with tiny functions, right? But I don't know if it is bringing any more value than that file in itself, right? Because you would essentially have the same functions, but instead of writing all this boilerplate, you will say parse module item, right? And this will mean the same thing as implementing parse for module item. And you will still have the same return value here, but instead of self, you will have to type the module item, right? For example. Now, one difference is that you could have access to the parser itself, right? As a mutable reference here, or not. And this will actually help you with a few things, such as directly manipulating the diagnostics vector. If you find something that you want, then you can just put it there. It could also help short circuit the parsing, right? By just sort of bubbling up the error. I think in the newer Caramel parser, the way I did this was by racing, actually. So the entire recursive parsing works just on nice data, and then at some point, some of the errors we have, right? Oh, this expect function, for example, that is defined here. It just calls expected symbol, and this just races, right? Races a parse error. So this makes it rather motorcycle coming through. This makes it rather convenient to just work on good data, and then when something is wrong, then you're just like, all right, I'm done, race it. But the top level interface actually catches those exemptions, right, and does something with them. But I presume that this parser actually has the exact same problem that we're having right now, where if the last thing you're gonna parse runs out of a file, right, to work with, then you're screwed. Right? You can't really backtrack and say, oh wait, I was in the middle of something, I'm going to just run the diagnostic for that thing. So there's definitely something to explore for the next time, right? So maybe for next time, we want to say, how do we ensure that all expressions get their diagnostic in even when we are out of a file? And that will be one thing. I think we can put the wish list aside for a second. I would really like to figure a nice way of doing that, right? The other thing that we want to be very clear about is distinction between parsing errors and diagnostics. What is this, right? Because there are a lot of conveniences in the Rust ecosystem for dealing with, I guess, diagnostics as parse errors. I guess Miet is a good example of that. If you treat all of your parsing errors, right, as diagnostics, then you get a lot of nice things in return. But maybe I'm missing some example here that shows me how would I be able to collect, right, any number of these diagnostics and then push them out. Or perhaps even better, right, if I had my own way of doing diagnostics, how would I feed them into the error reporter, which will help me just deal with this data in however shape or form I feel like, right? I guess multiple related errors there. Ooh, that's fun. And then just say, hey, please deal with this thing. Maybe this is what we want. Oh, nice. Yes, this is exactly what I want. Okay, Miet, you're awesome. Related. Back my error. Oof, definitely a lot to play around here. Play around with here. Okay, so I think we've advanced quite a bit from where we were last time. Let's do a diff. Let's see. I think the tests are still passing. Cool. We'll do a diff. We got some packages, some dependencies. We got some things written down in our goal. Actually, I'm gonna do one thing, and I think I'm gonna rename the goals to Captain's Log, just to keep with the Star Trek vibe. I think that'll be great. And then the wish list, I don't know if it's worth keeping it around. I think we'll come back to these things. Ooh, a little too aggressive there. And the last thing we have here is sort of the notepad, where we've been sort of writing down, jotting a couple of things, right? I don't know how much more of this we will use. So I think I'm just gonna drop this into the Captain's Log. I'm just gonna write like notes. There we go. That will do it. Cool. So now we can remove the notepad too. Too many files. Excellent. So in reviewing our changes, we've wrapped the original lecture into a new lecture that implements some more functionality that we need, right? And we are actually doing something in the executable. Not too much as yet, but you know, we're reading the files that you pass in, we're parsing, and we're spitting out diagnostic errors in a crude way. Everything else we've done today is new. So diagnostics new, error new, parser new, parse tree and tokens in a separate file also new. All right, so I'll just commit all this stuff for this stream, right? And we'll do a fit begin parser. Hammer. Give me a hammer. There you go. Cool. I'm pushing this up. Oh shit, yeah, I completely forgot. The source code of this thing is actually live at Abstract Machines. Where is it? Lower QLank. Here. Shit, 7 stars already? Who are you? Like, follow, on more, and all the things that people say on YouTube or whatever. All right, let's actually like this. Who has started already? No, I want to see. What? Okay. Wow. Super cool people. All right. I think we're actually going to call it a night. It's 3.5 hours of streaming. It's after 11:30 p.m. for me. So I am going to go to bed. But thank you so much, folks, for the time. I hope you really enjoyed this as well, as much as I did. I'm, a little rusty, right? With a couple of things here. Not because we're writing Rust, but yeah. And I will see you sometime soon. I think that tomorrow I'm definitely not going to be able to do this. Again, got some plans. Same for Saturday. But if everything goes well, Sunday night I might be able to put a short hour or two. And I don't know, maybe we'll get to clean up some of the diagnostic stuff. Or just do the one thing, figure out how to get those that nice state in the parser that says we are done, or we are missing stuff, so we will raise a diagnostic. We'll think about that. Anyways, thanks again for the time. I hope you have a nice evening or day. Stay safe. Cheers. How the hell do I turn it off? Oh, yeah.